beginner-friendly data engineering project on insurance claims and fraud monitoring. And that's exactly what we're building in this video. This project gives you a complete blueprint of how modern data stack pipelines are actually built. Starting from storing the data in NoSQL database, moving it into data warehouse, transforming it using DBT, and turning the data into visualizations. Just like the real world projects. If you're new, you'll find it easier to follow and hands-on. And if you have been learning with me already, this will strengthen your foundation and show you how all the pieces connect practically and professional way. By the end of this video, you'll not just have a project to practice, but also a clear picture of how data engineering actually works. Let's hop in. To begin with, like I said, this video is dedicated to the beginners who are just entering into data engineering domain. Well, I already uploaded a few videos about the projects that I worked on in this channel, but those projects might be pretty tricky or pretty complex for a beginner to understand. And also, I got a few comments asking for a more beginner-friendly project so that they can work on it. And yes, I would say yes for that. Because when you're getting into data engineering, learning theory is a separate thing. But learning theory parallel to hands-on experience by working on these projects makes your learning faster and also more efficient. So yes, that's the best way to go with. And today, in this video, I'm going to explain how data engineering works along with doing a basic project with a basic pipeline. Any data pipeline starts with the data source. And it mostly be an OLTP, which stands for online transactional processing. This is basically a database. OLTP stands for online transactional processing. Like it says, this database handles all the transactions. Well, let's take an example of an e-commerce website like Amazon. Any transaction done in that web portal or application is a transaction, and that transaction is stored in OLTP. Well, all the transactions are stored in this database for long enough to retrieve the data and store it into data warehouse, but they are not stored for longer times. They're just stored long enough so that people can use that data. So this is it. So transactional, there is OLTP and there is OLAP, and OLAP comes after OLTP, and I will explain about it in a minute. For now, OLTP, like I said, it's basically a database, and databases are of two types, SQL and NoSQL, as far as I know. So there is SQL and NoSQL. SQL databases are structured or they're structured with relations, basically known as Relational Database Management System, RDBMS. So they are structured and they're all connected. All the tables that are in the database are connected using relations. So that is that. And they also have primary keys, foreign keys constraints to maintain these relationships between the tables. And whereas NoSQL doesn't have any structure, doesn't have any relations, doesn't have any keys like primary key, foreign key, constraints, none of those. They're just, all the data is just stored in collections as a file, whether it can be a document or it can be a row. It doesn't care, it just stores as a file. And like the name says, there is no need of SQL in this database. Well, there are merits and demerits for both of them. Whereas the merits in OLTP is it complies ACID. ACID stands for atomicity, consistency, and isolation and durability. All these four concepts are applied for most of the SQL database, whereas NoSQL, few of the modern NoSQL database also complies this, but not all of them. to explain ACID, let me just like I said, atomicity, consistency, isolation, and durability. All this holds their particular value for SQL database. For an example, atomicity is nothing but all or nothing. It can be, it should be all the commands given to the database should be executed or nothing should be executed. Let's say we have a banking project. Well, we worked on banking project in our last video. Well, we have a banking project and there is a transaction done. Person A pays to person B. So we have to do two queries here where person A should be subtracted with the amount he sent and person B should be added with the amount he sent. Let's say A transferred $100 to B. So we do two queries in one code block, and under that we commit the changes, right? So it should be either both of these should be executed or none of these should be executed. It cannot be just A loses $100 but not B gain $100. It should be both or none. So that is what atomicity makes sure of. And there is consistency where, let's take an example. For bank balance, A has bank balance of $100. It can be positive, but it cannot be negative. So that is what we make sure in SQL database using constraints. It cannot be negative value. It should always be in positive value. And that is one more aspect that SQL database offers. And there is another thing, which is isolation. For this example, let's take a movie ticket. There is just there is a booking for a movie in a movie theater, and there is only one ticket left, and both the person A and B are trying to book the ticket at the same time, and there is only one ticket. And if it is not secured properly, not monitored properly, both of them get the ticket, but there is only one seat left. Yes, so it shouldn't be done. For that, if A books it, B will be displayed an error while he's booking, so he will not be booked. He cannot book any tickets after A booked it. So yeah, that is what isolation means. Every single person is isolated. So all the transactions done or any actions in the database are isolated for that particular transaction, and they cannot be done in parallel. And yes, and one more thing, the durability. For this ensures that once a transaction is committed, it changes. Let's say if you written a query and said A deposited money and he deposited $100 into his account, and once the change is committed, we cannot lose the data. It is permanent. It is permanently saved in database. So once the query is executed and once the change is done, it will be there. So that is what durability means. That is basically ACID. The main difference between SQL and NoSQL is ACID properties. And there is, yes, like SQL has its own advantages, NoSQL also has advantages. It is scalable, it is flexible, where the data type, let's take an example of data type. Any for data type of any column in NoSQL can be changed anytime it wants, because NoSQL doesn't store any data types of the data, whereas in SQL it stores all the data, and also it is also structured. So if there is any changes done, NoSQL is so flexible for that, but whereas SQL is not. And also, if you want to do modifications for the data, for the structure of the data that you are defined already, it is so hard for SQL, whereas in NoSQL it is so easy. For instance, let's say you have two entities. Let's say you have two tables created, and they are related. Okay, so they are related, and table A, let's say this table A, this table B. Let's say table B has a foreign key that refers to table A. So if you want to delete table A, no, if you want to delete table B, you need to delete table A first. Maybe I have to make it more clear for you. Let's say table A stores the biographical data of a customer, which includes a customer name. So this whole table has a primary key that should be unique for every record. So it has a primary key as customer ID, and let's say 1. And this customer ID is referenced in this table. This might be any table. This customer ID is referenced here, and here it is primary key, and in the table B it is foreign key. So if you want to delete table B, I don't know why I entered equals 1. If you want to delete table B, or if you want to delete table A, you need to delete table B first, because it has the primary key inside table A referenced by table B. So you have to delete the table A first, and then you can delete table B. So this is one of the demerits of SQL database, and applications of these two databases varies according to the requirement. Whereas like banking, or let's say YouTube, banking, anything related to banking like transactions should be done with SQL database, because it has the ACID properties complied. Whereas in NoSQL, we can use that for e-commerce sites, where we don't basically need the structure, we just need the data, and it should be more flexible to scale. And yes, that's the difference. Let me take these out. And yes, it starts with OLTP, like I said. And next, from here, the data transfers to OLAP. Let me just copy paste this box here. So there is OLAP, which stands for Online Analytical Processing. Online Analytical Processing. This is basically a data warehouse where the data gets stored and transformed and make become business ready. After the data pulled out of the OLTP layer, well, like the name says, online analytical processing, all the analytical all the analytical work is done in OLAP stage, where we use a data warehouse. It can be Snowflake, it can be Synapse in Azure, so it can be anything, where the data stores and it is manipulated, it is cleaned, and then we connect our visualization to OLAP, which is our data warehouse, and pull the data out. So that is it. Between these two, OLTP and OLAP, to transfer the data from OLTP to OLAP, there is one single layer, one particular layer where we use to link these two services, which can be a streaming engine, or in our case, we're going to use Airbyte. I'm going to call it conveyor belt. Should I name it conveyor belt? Let's say transporter or transfer. So this action is done by tools like Airbyte, which is so beginner friendly that we're going to use in this project. And there is Kafka, which streams the data online and later pulled out using a Python code. It can be DAG or something. And there is Kafka with Debezium that is mostly used for SQL databases, where it captures the changes and stream using Kafka. This is basically like a conveyor belt in a factory, where the products are transferred from one station to another station. This is like a conveyor belt for that. And in our case, we are going to use Airbyte. So the data transfers using this transfer application. We can call it transfer application. Transfer application to OLAP. Now in OLAP, the real transformation of data occurs. OLTP, because the data in OLTP is not structured, is not more like structured in a way that we can use for analytics, because it is basically its main focus is to handle the transactions. So it should be faster, but not not organized in the right way. Whereas in data warehouse, we organize the data. It is like any other, it is like an Amazon warehouse, where the products or the goods that are delivered are all organized in the way that makes it easier for the people to access. So to do that in OLAP, we're going to do data transformation. So the data transformation is done while the data in data warehouse. So it changes, it cleans, and the cleaning refers to anything like taking out null values or recognizing the false, and also changing the column names so that they are readable, and the final data that we get should be business ready, where we can use that in the next process, which is analytics. And yes, data transformation is done over OLAP. So to resemble that, what can I do here? Let me just put a box around OLAP just to resemble that, and fill it with nothing. One more box for all the data transformation is done in this stage where the data is stored in the warehouse. And yes, from here, the last step, which will be data visualization. It can be any visualization tool. Let me arrange center back. Connect it from here. Yes. Nobody wants to see the data, see the raw data, and take business plans. So, in order to get the insights out of the data, we change the data that we get, all the numbers, into actual visualizations. So business owners can take business decisions just by viewing at our charts. That is what we're going to do in this layer. And that is it. I think data visualization, by the way, includes the tools like PowerBI, Tableau, and many others. But these two are the most popular tools in data visualization. And this is the whole blueprint. It's a basic blueprint that any data pipeline out there follows. Any pipeline. To be particular with you, this is the extraction step. We are extracting the data from database, and we'll load it into OLAP, and then we transform it. This is OLTP, and there is also not OLTP. It is ETL. No, it is ELT. There is another term you have to know, which is more important. There is ETL, and there is ELT. And these three, the end result is same, but the process is different. Where E stands for extract, and T stands for transform, and L stands for load. The data is extracted first and transformed before loading into data warehouse. This is one of the steps, and there is another that I just explained, which is ELT, where the data is extracted and then loaded into warehouse first, and then transformed while the data is in the warehouse. This is another type. So there are these two types of transforming the data. Well, this blueprint is for extract, load, and then transform. Any pipeline that follows ELT basically does this. And there is, on top of this, there are data quality, which includes slowly changing dimensions, schema evolution, star schema, all this. And also there is enterprise practices like CI/CD, DevOps, and stuff like that. All of that comes on top of this. This is the blueprint that you have to know before stepping into data engineering. Any project should follow this. Any project that follows ELT should follow this. And ETL is a little different. Just the transformation comes before the loading. That's it. And okay, now stepping into our project. In this project, we're going to use MangoDB. Let me just import an image to show you what we're doing. I'm going to use MangoDB here. Just make it small. So we are going to use MongoDB as our database, which is a NoSQL database. So you don't need to know much about SQL whatsoever to do this project. It's not great. Why it is not moving? It is locked. Okay. So it starts with the database, which is MongoDB. Let me name it database. Should I database, which is MongoDB. So this is the OLTP layer of our project. Then next it goes to the one that the conveyor belt, which is the transfer app that transfers the data from database to OLAP. For that transfer, we're going to use Airbyte. We're going to use Airbyte because it is so beginner friendly, so anyone can understand it. So it doesn't need any coding for this, coding knowledge at all. It is so helpful to demonstrate how this linking actually works. Well, Airbyte is our conveyor belt here. And then for OLAP, we have Snowflake. We are going to use Snowflake as our data warehouse. This is it. There you go. Let me just box it up. Lake, and this is our data warehouse. Okay, like I said, now after the data is loaded into Snowflake, our next step is data transformation. There are a lot of tools out there for data transformation, which include DBT, and also there is PySpark and a lot more tools out there. But we are going to use DBT. DBT actually needs a basic knowledge of SQL to transform data. And yes, in our project, we are going to use DBT for data transformation. Let me just outline this. Yes, now we got something for the data transformation as well. And now the visualization part, which is going to be PowerBI in our project. I don't know why, but for me, I also work with Tableau and also PowerBI, but I think Tableau is more beginner friendly than PowerBI because it is so easy. Well, I don't know about any other, but I think personally, I think it is the easiest tool you can start with. Yes, this is our data pipeline. Very small one, but does the job. Moving forward, we have the architecture and we talked about the plan that we're going to follow. I think now it's a time for the demonstration. But before starting with our step one of creating database, let's create a repository, a folder where we can manage all our files that we're going to use in this project. For that, let me open command prompt. If you never used any terminal like command prompt or PowerShell or Bash, I'm going to tell you how it works. It's basically like having more control of your work. Any terminal lands at this location by default. C users J. It should be in C drive, users folder, and your username. That tells you basically you are in this folder. So whatever you do in this CLI, in this terminal, reflects into your UI, which is file manager. So yeah, let me run a command to show you how it works. So this is a command to create a folder at this desired location. mkdir stands for make directory, which means it makes this a directory, a folder named with this. And you will be able to see the folder in the UI right here. Right now it will be empty because you just created an empty folder. Now I'll run cd. cd stands for change directory. You can run that command to change your desired directory. Now you're basically in here. Now any changes you do here will reflect here now. So now you're here. Now let's create another folder name. Name it data generator. Now you will be able to see that in the UI. Yes, we have the repository. Let's minimize this first. Moving forward, for the database, like I said, we're going to use MangoDB Atlas, and yes, Atlas provides a free trial for anyone with a new account, and it doesn't. You don't need any card. You don't need to put in your card details or anything. You just need a new email to get the free trial. So yes, here it is. Now this is the home page you will be redirected to when you create the account. And when you're here, you can create a cluster. Cluster is like a machine, just like your PC, but this is a cloud machine. This works online. So the load is not handled by your local PC or your laptop. It is handled by this online, this cloud PC, basically, a cluster. Now, I'm naming the cluster as insurance. Provider can be anything for now, we don't use anything. And the region that is close to you. After that, hit by the way, make sure you chose free trial, free tier, because these two cost money. Hit create deployment. Now you deployed the cluster. Now the database is ready to connect to an application. Well, we don't have an application, a real application with us, yes. So where we get the data from? We use a Python code which basically simulates the real-time data and starts a stream and produces the data until we interrupt it. Let me show you how we can do that. Here, this is the code. By the way, this all the codes, this code and any code that I'm going to use in this project will be available to you in the GitHub, and the GitHub link will be posted in the description. So this is a simulator. This is the Python code that simulates the real-time data, just like we're getting from API. But in real world projects, this data will be coming from a real API or any sorts of source. But yeah, we don't have any, so we have to simulate the data. Okay. So yes, here, this is the simulator code. Now first, let's take a look at what we are dealing with here and how this Python code works, what it generates. So you will have a clear idea of what data we are working with. I think I haven't mentioned to you, we are going to work with an insurance project. Yes, beginning with, these are the requirements, these are the utilities we are going to import, basically the modules from the libraries. So we are first importing Faker from Faker library. Faker is used to generate the fake data that is so that looks real but it is fake. And then we import random. It is used to pick a random object from a given series of data. And then import time to get functions that use time. And also import PyMango. We use this module to connect to MangoDB from Python. So we use PyMango for that. Faker equals, we assign the faker to the variable name. This is a variable name. It can be anything. It can be named anything. If you know basics of Python, this is just a variable name. We are assigning this method. And then this whole part is the configuration of MongoDB. Firstly, we start with the client, a PyMango Mango client. The client will, and the connection string will be available in our MongoDB web UI. And I will show you, I will fill these things after I explain the code. And this is DB client. And these are cluster name. And this is our collections name, customers, and we are going to create a collection name claims too. And we start an infinite loop with while true method. When we use while true, it just loops over and over again unless an external user stops it or interrupts it. It means when we start running this code, this loop will be executed endlessly unless we stop it. In that loop, first we create two dictionaries. We know about the data types that stores multiple objects in Python. We have dictionaries, we have lists, we have tuples, we have set. All of them have their own conditions, own merits and demerits. Well, we use dictionary here, which is basically a key value pair. So we reference any value, let's say this one, with a key with this one. So if you want to call this value, we reference it with this key. Let's say if I want to call that, I would say customer of customer ID, and this reference to this value, it will return this value. That's how a dictionary works. And yes, we have two dictionaries here. One has customer biographical data, and the other one has claiming data. Firstly, in the customers dictionary, we'll create a customer ID which includes f strings. If you don't know f strings, if you never used f strings before, I'm going to say a few basics of f strings. F strings is basically like creating a dynamic string that changes according to the values you pass it. So to particularly explain it, I'm going to show you an example. Here, f strings, you can type in anything, whether it's an integer, it's a string, everything is taken as a string, but you can include a variable that changes dynamically using a flower bracket in between the string randomly in any location you desire, and we can call a variable. Let's say if I say fake here, it calls the variable this one, which will be this one. This will be printed inside that and will be part of it. So we can call anything inside a string using a flower bracket in f strings. We have a lot of applications with f strings, but this is the basic that we're going to use in this code. And yes, here we used f strings. Like I said, anything inside will be a string. So the CUST, customer, and the hyphen will be a string. And this is dynamic. When we say random.randint of 100, 999, before going to f strings, we have to know about this. So random has a method called random int to choose a random integer in the given range. So there are a lot of methods in random. There is rand integer, which chooses integer, and there is also the random.uniform to pick a random decimal number in the given range. So we used random.randinteger, which picks a random integer from the range of 100 to 999, any random integer for every loop. So yes, it assigns that, and this will be part of this string, which will be, let's say if the random.randin picks 150, then this f strings prints CUST hyphen 150. This will be the output of this f strings, and this will be assigned to customer ID. Okay, take that out, and yes, and next there is name, which is given value as fake dot name of. Here, like I said, fake generates random stuff. Using fake dot name of this method, we can generate fake names. So that is what we're doing here. And then state, fake dot state ABBR of, which generates a random state, a fake state name. And we have policy type random.choice of auto, home, health. Just like I said, random have a lot of methods, and choice is one of them. Random.choice picks an object from a given list. So we have given this list, and random.choice picks any one of these for every loop. And once it is picked, it is assigned to this key, policy type. There is auto, home, health. Yeah, that is with the customer dictionary, and we have claim, which includes claim ID. And like I said, f strings, this whole thing is a string, and there is random.randint of 1000 to 9999. So it picks any number from 1000 to 9999. And there is customer ID, which is customer of customer ID. Like I said, we can reference a value in a dictionary by using its key. And this is the dictionary that we already defined, and it will pick the customer ID using the key. And from that dictionary and assign to this key in this dictionary named claim. And then we have date, fake.date between start date equals -1 year, which means anywhere from, and end date. End date refers to the end date, and this is just range of where we need that fake date from. And it will be between today and anywhere between 1 year from in the past, and that will be converted into ISO format. And then we have amount and random of random.uniform of 100 comma to 20,000 comma 2. Firstly, talking about this, like I said, random, that is one of the random method. Uniform, random.uniform returns a decimal value from a given range, which is 100 to 20,000. It picks a random decimal value, and then the return decimal value can have many number of decimal point values. Let's say it can be, for example, it can be 34. No, it cannot be 34 because the limit is 100 to 20,000. So it can be 4,500, and the decimals can be any long. So it is not controllable. For that reason, we use round off, and we specify the decimal point, the precision, using this number. So the output of round off, this decimal comma 2 will be 4,500 point, can be somewhere around 89. So it can be this one. So it just takes 2 decimal point values after the actual value. So it just basically rounding up the decimal points, so it is not too long. And yes, that's how it works. And then we have claim type, random.choice of accident, theft, fire. Like I said, random.choice picks any object in the given list. And we have isFraud, random.randomoff. Well, random.randomoff method prints any decimal point value between 0 to 1. It can be anything. It can be 0.5, it can be 0.4, 0.3, 0.32, or with any precision. And yes. And why do we use less than 0.05? Means the center of 0 and 1.0 is 0.05. So we're just checking, we just want to print true for the 50% of the time and false for the other 50% of the time. And yes, this whole thing returns a Boolean value. It can be either true or false. And what random does, like I said, it returns any value from 0 to 0.1, 0 to 1.0. So the chances of the value being less than 0.05 is 50%. And also the chances of it being greater than 0.05 is 50%. So we're just making sure that the Boolean value, true or false, is assigned to isFraud. The chance should be 50% true, 50% false. And that's what we're achieving here. And yes, with that, we created the 2 dictionaries, and then this is for inserting into MangoDB. We say customers call.insert one customer call.insert one claim. We are inserting the customers into the collection name customers and claim into the collection name claim. We haven't created the collections yet in the MangoDB, and we will now. Okay, and then we print like I said, the f strings, anything in here is a string, and this one is a dynamic part of it. So yes, insert claim, and claim of claim ID just prints the claim ID and merges it with this string, and also the customer ID and merges it with this one. So it insert it, for instance, it prints like insert claim claim CLM and random number from 1000 to 9999, and then for customer, and the customer ID CUST, and a random integer from 100 to 999. And yes, you remember when where we imported this module time, and this method is used to take a break between the looping. Like the while true assures the loop is infinite, and time.sleep of 2 assures the loop repeats for every 2 seconds delay. Anything we specify here is the time delay that we're adding to the loop, and here it is 2 seconds. And yes, with that we are ready with the simulation code. Now we have to prepare our MongoDB for that. Firstly, before connecting, let's set the collections here in the left pane. No, here, not in the left pane, right here. Click on browse collections. Right now it has a sample database that is created by default. It'll be, we have to take that away. That's fine, we'll leave it. Yes. For our code, like I said, we need the connection string, and the connection string will be somewhere in the left pane. Go to database access. No. Be in the cluster page itself. Here, click on connect to your application, and in our case our application will be the simulation code. Now copy this thing, the connection string right here, go back to the code, paste your connection string this spot, and this is my username, and here I need to put in my password, the MongoDB password. So let me do that. So I'm going to show you the password as well, because it doesn't matter, but that's the password of the role that I have in the MongoDB. It'll be temporary, so I'm going to show you the password as well. Then yeah, I think that's it. It's just password 123. After you put in the password, client, yes, now save it. Save it in the repository that we created, username, this repository, this part, and name it something like simulator.py, and we have to switch the type as all files, so that this file is saved as a Python file. And then encoding should be UTF-8. Now save it. If everything goes well, we should be able to get our file inside our desired location here in Python file type. Now, head back to command prompt. Make sure you are in your project repository that we just created, and now here run Python and simulator.py. It says can't open file because no such file in directory, because I saved this file inside data generated, but in the terminal we are inside here. So we have to go inside this folder named data generator. Like I said, to do that we use cd data generator. Now we're inside there, and now we can run this command. We should be able to see one record inserted for every 2 seconds. It says inserted claim. Like I said, this is the static part of the print statement for the f string, and this is the dynamic part which shows the claim ID and the customer ID. And this stream goes on until we interrupt it manually. We can interrupt it using Control plus C, or we can just close the whole terminal and it stops automatically. Either way, it works. Now the stream is running. Now we should be able to see our data in our database. Click done. Now head back to collections using browse collections. Right here we see our database named insurance, and the tables are created automatically. But whereas in SQL database we have to design the structure, we have to define the tables with the data types and everything. But whereas in NoSQL it doesn't need anything. Like I said, it is so easy. It doesn't have any structure, it is fast, but it is not secure enough like NoSQL. So both have their own applications. Well, we have in this collection we have 2 tables. Basically these particular things are called collections in MangoDB. Claims is one collection and customers is another collection. And the data here can be seen in here, and we can query it as well here using filters. And yes, if we take a look at it, it says the customer ID and the name that we generated randomly, and the status, state and policy type. And yes, the data is here basically. So we are done with our first step, establishing the database. Now we need to establish the conveyor belt that gets the data from database to Snowflake. But before defining Airbyte, the data transferer, we need to define the destination where the data needs to put in. Yes, so the destination will be Snowflake. And yes, Snowflake is also free for 30 days for anyone with a new email. You don't need to put in your card details or anything. So Snowflake is free. Let me open that. This is the home page for Snowflake, by the way. And yes, like I said, it gives you 30 days and also $400 worth of credit. And you can use all those credits. And I still have 268 credits left after I used it for 23 days now. And yes. I have the data here, and it is still, the stream is still running. Now we need to create a database inside Snowflake where we can store the data in. No, not the database. I mean, well, yeah, we need to create a database inside the data warehouse to store the data in. To do that, you can click right here, or we can use queries to create database. Let's use query. Click on the plus symbol, SQL worksheet, write the command, create database, and name your database. Select that, click on run. The database insurance successfully created. To check that, we can head to catalog, refresh, click on the refresh button, and there you go. There is the insurance database that it created. Now head back to the worksheet again, create a schema, create schema, name it raw. To refer it as a raw data, I'm going to name it raw. Head back to catalog again, and yeah, there you go. You can see that raw. This Airbyte internal and all the stuff. These about the these are my all the records that I created before doing this project, and I somehow they are retrieved back. I'm going to drop them. I think it's some kind of a glitch because I just deleted them. But it says they are not exist, or don't have I'm not authorized for that. But yeah, I think it's a glitch. Now they are not here. And these two are the default schemas that get created whenever you create a new database. And yes, this is the data. This is the schema that we created. Now the data that we're getting from the MongoDB will be directed to this raw schema. To do that, we have to head to Airbyte. Airbyte is also free, I think for 14 days. And yes, this is the homepage you land on, and you don't need any card details to get the free trial. And in your homepage, it right away says create your first connection. Click on that, and here first we need to define the source where we get the data from. Our data source will be MongoDB, or you can search here using the search bar. Whatever, you can see you just need to find the MongoDB, and yes, click on that. And we need to define the destination, which will be Snowflake. Well, they're pre-defined to define source. They're showing me the only, oh, it says select an existing, just okay, I got it now. So it is showing just one option here because I already selected this before, and it shows the existing sources. But if you're creating a new one, this will be the screen you'll be viewing. Here we need to find MongoDB. Right there you go, right here. And also name it. I'm going to name it by default MangoDB, and I'll leave it. Cluster type, connection string, the same connection string we used for the generator code. I'm going to copy that, paste it here, and database name, which is insurance. This one, the database name insurance, and a collection name. Oh, it doesn't need collection name. Okay, user. And password. Authorization be admin. Now, before connecting to the MangoDB, we have to, MangoDB is so secure, so it only allows the IP addresses that are accessible, that are given, that are defined here in the network access. So I already did this before, but I'm going to do that again just to demonstrate how we are doing it. I don't know which one I took out, but let me check. Yep, I'm going to delete everything then. Yeah, like I said, MangoDB only allows connections with the IP addresses that are defined in the network access. But if you want to connect to Airbyte, we need to define all this. We need to specify all these IP addresses in the network access in MangoDB, one after another. You have to click on add IP address, and here, access list entry, you need to copy paste every single IP address here. Don't need the comment, and say confirm, and do that for everything. Let me do that real quick, and yes, now I put in all the IP addresses and they're all active. And yes, now we'll be able to connect. Click on setup source, and it tests the connection, and it takes a few seconds. So if it's successfully connected, it says it's successful, or it pops an error if there is any sort of inconvenience. Yes, the connection is successful. Now it switched to define destination. I'm going to set up a new destination. Search for it is on the right at the top. Click on Snowflake. Here for the host, like it says, you have to find this host address. For that, head back to Snowflake, and in the bottom left, click on the username, and here click on session details. You'll be able to see this in a Snowflake context from, wait, I think it should be, yep, from this one, right next to the double slashes, copy everything and paste it here, and the role, it is account admin, like it says here. Say account admin, and the warehouse name will be in the compute warehouses here. Mostly it will be compute WH by default, but if you create any warehouse or rename it, it will be different. Mostly it should be compute WH. It says suspended, but it will be active think we just need to refresh it. It will be active. Yes, and database. The database name is insurance, and that's and default schema that we created is raw, and username, your Snowflake username and password. Authorization method can be anything. It can be key pair authentication, or it can be username and password. I'm going to choose password. And click on setup destination. The same thing, it takes few seconds. If there is any sort of inconvenience, it says it pops an error or it connects successfully, and switch to the next step. Yep. So it is successful now. Now we need to select streams. Well, Airbyte is so easy because it is beginners friendly, but most of these Kafka streams might not be this easy. They're not so hard as well, but not this easy. Well, we need both the collections, so we're going to select the whole database with the two streams and click on next. These settings can be defined by yourself. This can be changed according to your specifications. I'm going to go with every 3 hours, and destination is defined as raw, and yes, stream prefix, no. Click finish and sync. Now it is syncing. To sync, you should be able to see your data when you refresh and extend the schema. The new tables will be inserted, and these two are inserted automatically by Airbyte, which has everything, the metadata of the data that we are doing. Metadata is nothing but data about the data. Yes, but these are our main two tables that are getting inserted, and we should be able to see our data, but also a few other columns. Like I said, it also has metadata included, which is Airbyte raw ID, Airbyte extracted at meta, which are added by Airbyte. Shows CDC. CDC stands for change data capture, and it's CDC deleted at, updated at, all this stuff. You'll know more about CDC and these two, deleted at and update. All this stuff will be like overwhelming to you to know, but for now it's better to know our records are here. You see the claim ID is fraud, claim type, customer ID, and also that's it for the claims. And for the customers, we have name, state, customer ID, policy type, and yes, that's it. And we have we generated 609 with our stream. And for Airbyte syncs the warehouse with the database for every 3 hours. That is what we specified. It can be anything, you can specify it, but I did 3 hours, so it syncs automatically for every 3 hours. And yes, we got the data into warehouse, which means according to our plan, we're done with database stream, and we push the data into data warehouse. Well, to run DBT, we need to initialize it first. We need to install it first, and then we need to initialize it. To do that, open command prompt and run pip install dbt core and also dbt Snowflake, because we are doing the transformation in Snowflake. I spelled it wrong. dbt core and dbt Snowflake, run. After installation, you need to head to right now you're in the root of the repository, but we need to head to our actual repository, which is this one, insurance NoSQL pipeline. And inside here, we need to initialize it. To initialize DBT, we run dbt init ins underscore dbt. It can be anything. This name can be anything. This ins dbt can be anything you like, but I'm going to go with ins underscore dbt. When you run this, it asks for a few steps. We need to select Snowflake. It gives you options to select. We need to select Snowflake. Click 1 and enter. Now for the account, you need to head back to Snowflake and bottom left, click on session details. Now you don't have to copy the whole thing now. You just need to copy until here. Everything before .snowflake and after /. Only that part, and paste it here. Run. And enter, and then username. Now you have three ways to authenticate, but I'm going to go with password again. Type in your password and then role account admin should be account admin warehouse compute underscore WH. Database is insurance. Same thing. Everything that we entered to connect Airbyte with Snowflake, it asks everything the same. So the schema should be now for this one, for DBT, let's create a new schema. We named it raw, but for the analytics ready data, we need another schema to store it so that we don't confuse. So let's open the worksheet. Let's use the old worksheet that we already have. Here, let me create another schema and name it analytics. Now you'll be able to see another new schema called analytics. Now I'm going to run DBT, store the data in analytics now. For that, I'm going to type in connector. And threads, it depends on how much the load is. And for us, it is not much. So we're going to use one thread. It is about processing the data. The more threads you specify, the more faster you get the processing. So yes, for us, it's not, it's a one is fine. So I'm going to specify one, and yes, now it is connected. You should be able to see Ingest DBT. That is the folder name that we specified when we initialized DBT, and the logs for DBT. And you should also be able to see .dbt here with the profiles, which should include your password and username and everything inside that file. Now we have to write the transformation queries in SQL. For that, I'm going to use the SQL workbook just to write the queries, but I'm not going to save them. You can write this directly in Notepad as well if you want to, but I'm going to write it here. First, we need to define the source so that the DBT will know where to get the data from. We need to define it using, I need to do it version 2. Sources, hit tab, space name, source as Snowflake, the database, our database name is insurance, and our schema is analytics, tables, hit tab and hyphen, space name, claims. Yes, now copy the whole thing, open a notepad, paste it in a new notepad, now save it. Name it source.yml, and to make sure the file will save in .yml format, we need to change the type as all files and UTF, and also it should be saved in Ingest DBT models right here. Save it. And by the way, you can delete this. This is just an example for DBT model. You can delete that example inside the models, and then we're going to create a few views. First, let's start with just to make it look good. Select. By the way, you don't need to give the spaces that I'm giving. It's just to make it look good and separated. And yes, if you want to, that's fine. You can just hit tab here and double tap here. Yes, and claim ID. Customer ID. To date. Yes. Let's copy that and paste it in a new notepad. Now I'm going to explain what we did here. Here, remember when I said you just need a basic SQL knowledge to understand the code? This is what I meant. You just need to know what we're doing here. Well, here we just created a CTE, common table extension. This is like a temporary table that we're going to create here, and then we reference it using select and select everything from that. Yes, in this CTE we selected claim ID from where? Claims, which is in the Snowflake. Let me just open that. Claims, data preview. This is the source that we specified using the source from the, wait, yeah, and here we are sourcing from claims. We selected claim ID, which is this one, and then we selected customer ID, which is this one, and then to date of date as claim date. Is there a claim date? Right here, we use this as claim date. We are converting it to date using toDate method in DBT. We are converting into date. Right now it is just a string. It is stored as string, but we have converted it into date format. And this is one way of converting the format using amount double colon is a DBT method of converting a given column into this data type. So now the amount is converted into float data type here and aliased as amount. Yes, and the amount should be here, right here, and amount is here. And then we selected claim type here, and then is fraud boolean as is fraud. Well, like I said, is fraud is true or false, so the type should be boolean, and these two columns is the method to convert the given column into this data type. Yes. Now we selected everything. We given the data types. We assigned the data types that required the data that requires the data types. And yes, we have all the data, and we have all the data in CTE. Now we need to get that into the main table using select all from raw. Raw is the CTE name here, so we selected everything from the raw. And by the way, we are creating a view. There are few types of data models. I think we call the data models of tables in SQL. There are a regular table, there is a view, there is snapshot. So the table is a table that we create just like this one here, but the table has the data stored locally, which means it is not dependent on anything. The data is locally stored in the table, but whereas views, the data is not stored locally. It references another table that is outside and gets the data out of it. And you might wonder why we are using uh, view when we can just use table. Here's the thing, views updates whenever the reference table updates. So views automatically updates when the reference table updates, but table cannot update by itself. We need to manually update it every time we want it updated. So here's the thing, but that's the best part of the view, but there is a demerit, there is a downside of the view as well. So if we create a view, if you want to query something, views are relatively slow compared to table, because view has to go back to the reference table and get the data from that, whereas table store the data locally, so it prints it. We can query the data faster, and that's why they both have equal merits and demerits. But here we are creating views which updates automatically. We don't need to do anything unless and until this source table updates, the views updates as well. And there is snapshots, a separate concept which is more likely used to for the concept called slowly changing dimensions, SCD2, where it stores the historical data for each and every record. So I mean, it becomes complex when I talk about these table types, but yeah, these are the two main and basic views, basic tables. One is the table, and the other one is the view that SQL offers. Yes, we are creating a view here using the DBT. So we will name it claims. Name it STG claim. And at the end .sql, all files, save. So whatever we name the file with, that will be our the view name. Now when we run the DBT, this will be our view name that is created inside the database. Yes, this is the staging view that we created, and now for the business ready view, we're going to create one more. That too in going to use a workbook for that. Select date, get. Yes, in this, we're referencing the data from staging claims using from, which will be this one. From this view, we're referencing the data into this, where we are truncating the date with month and naming it as month. We're truncating the date truncate is nothing but combining everything with this particular parameter. So we're truncating the date with month parameter as and naming it as month, claim type, which we already have, and claim count as claims count. I think it's better to explain it from here first. We are grouping everything with the columns 1 and 2, which is month and claim type. We're grouping everything with month and claim type and ordering everything with month. So it orders accordingly, starts from the least date and goes to the highest one. So it is ordered by month and grouped by month and claim type. We are aggregating the data, and now we are now we are using count of. For that particular month, we are counting the claims that are in the we are counting all the claims and assigning aliasing it with claims count, and then sum of amount as total amount. For that particular month, all the claimed amount will be summed and aliased with total amount, and then we have sum of case. Case is like, we use case when we have a condition to go through with, and here the condition is when is fraud, then 1, else 0. Yes, when is fraud, then 1, else 0. So if is fraud is true, then it returns 1. If it is false, it returns 0, and this is to end the case. And it counts all the fraud claims that are done in that particular month and assigns it to aliased with fraud count. And all these columns will be called, will be referenced from staging claims. Now we need to name it using claims summary.sql. All files, save it. Now we have everything that we need. I think I forgot here. There should be space between parentheses and flavor brackets here. Yep, that's perfect. Save it. Yep. Now we have the transformation queries. Now we have to run the DBT. To do that, head to command prompt again and make sure you are in the folder that you initialize DBT in. Where I initialized it in INSDBT, we should be in here. So yes, run this command to do that. Now we're in that folder. Now here, just say dbt run. It runs everything that you specified to it. Well, we got an error. And what is it? That depends on the source name snowflake.claims, which was not found. There's something wrong with our source that we defined. What is it? Catalog, raw, schema is raw and claims. Oh, I said the schema is analytics. It's supposed to be raw because claims is in raw schema, remember? But the views we are creating, we are going to create the staging and the final business ready will be stored in this schema, but the source should be from this schema, raw and claims. So the source should be from raw. That's the problem here. Now we solved it and saved it. Run that again, dbt run. Again, now the same thing. Says insurance debit claims. What is wrong with it? Let me check. Well, I just found out the error. The error is with source, like I said. Here, we defined it with capitals, the claims, but in YML, we wrote it in small letters. So we need to change it with capitals as well. Like this. I'll save it. Now let's run it again. Now both are successful, which means we should be able to see our views in the catalog when we refresh and extend the analytics one. Under the views, we'll see both the views that we created. And let's take a look at the data in there. There you go. You can see all the data. And this is the staging table. This just has the data with the data types defined, but this is the business ready data that we created with using a few aggregations, which has claim counts, and we partitioned it using months and also claim type. Here it says for every claim type there is, for every month and for every claim type it is separated. Until here is for is for 9th month, and until here is for 10th month, which has different claim types: theft, accident, fire, and here theft, accident, fire, and until here is the 11th month, theft, fire, accident. So they are grouped using month and claim type. And we counted all the claims, remember, and we assigned it to, we aliased it using this name, claims count. And these are the claim counts and total amount, sum of total amount that we counted, and this is the fraud count that we counted. And yes, everything is ready. Now, in our architecture, we also transform the data. Now the next step will be visualization by connecting to a visualization tool, which in our case will be PowerBI. Well, installing PowerBI is pretty simple. You can find it in Microsoft Store, or you can just download it from any web browser, and it is free. It is not even, you don't even need any free trial or something for that. It's totally free. And when you open it, you'll land on this page. From here, click on get data from other resources. Search for Snowflake. Click on it, connect. Again, head back to Snowflake, bottom left, click on session details, and copy only the part that we used in DBT and paste it here. And warehouse be compute WH. Click on OK. It asks for username and password. Type in your username and password. Hit connect. You should be able to see all the schemas that are in the data. I mean, all the databases are in the account. Choose our database, which is insurance, and choose our data analytics ready, the business ready table, the view, which is named claims summary. Load it. Here's the thing. There are two modes of connecting data to Power BI, import and direct query. Import connects a separate entity, which is static data. It just downloads the data, all the records that are in the data warehouse, and that's it. It cuts the connection with data warehouse. Any data that is updated in data warehouse will not be updated in Power BI. But if you want your data be updated with the data warehouse, you should go with direct query, which updates according to the data warehouse. And that makes the data real time. And if we take a look here, we got all the data that we need. Now we can do anything we want. We can create the charts in this dashboard. But well, this project is not about data analytics tutorial. This is about knowing basics of data engineering. So I'm going to create a couple of basic charts, basic visualizations, just to make sure the data is working. Let me just create a few. Firstly, of course, to keep track on fraud claims, I'm going to create a line chart with the month as time and fraud count. And yes, there you go. We have a line chart that shows fraud for every month. And then we can create a KPI card by clicking on this, and total amount. This is the total amount of claims. Let's create another KPI card for fraud count. These are the total amount of frauds that are committed last year in our simulation data. Yes. And also one for the claims count. Yep, there are 609 claims. And with that, I think we're done with the whole pipeline. Let's take a look at the architecture one last time. Yes, we created the database and we pushed the data with a simulation code because we don't have any API, we don't have access to any API data. I mean, we can get access using open source API data, but for now we just use simulated data, and we got the data and stored in database, which is OLTP. And we transfer the data using Airbyte as a conveyor belt, basically. And then we stored the data into Snowflake, which is our data warehouse, OLAP, and transformed it using DBT, which is data transformation. And then we connected Power BI for data visualization. This is the blueprint. This is the basic model that any data pipeline out there will follow. Like I said, it changed accordingly to the method you're following. If it is ELT, it should be this model. If it's ETL, this data transformation will be done before pushing the data before storing the data in OLAP. That's the only difference, but rest of it is just this block diagram. And with that, our whole project is done. I know I almost took like 40 minutes or something just to explain what we're doing, because I want to make it beginner friendly, and I want to let the beginners know what we're actually doing here in this project. And yes, with that being said, this video is for our beginner series. That I'm going to add this video in a separate playlist named beginners. I'm going to name it data engineering project for beginners, and I'm going to add this video in that. And maybe in future I'm going to add few more beginner friendly videos in that playlist. But for the next project, I think I'm going to work on GCP. I'm not sure. I think I'm going to work on GCP, Google Cloud Platform. And with that being said, we're done with the video, we're done with the project. I will be back with a new video, new project. Until then, see you. Adios.